All right, today we're going to finish the notes kind of where the screencast left off. On the screencast, we talked about solving with radicals or exponents when there's an equal sign. Today we're going to look at the same type of thing if there's an equality sign. That means less than, greater than, those types of symbols. So number 7 on the back of your note sheet, we want to look at solving this one. So you can see we don't have an equal sign here, we have an inequality. But how you solve it's pretty much the same. You want to go through and try to get this variable, our x, alone. So we got to undo everything in order to get there. While we're doing this, it's the same thing as if the problem would have been an equation, but with inequalities, remember there is the one thing you got to remember about multiplying or dividing by a negative. If that ends up happening at any point, we need to flip the inequality sign the other way. So let's try this one out. We want to get this x alone. So our first job is to get this 2 out of here, and we can do that by subtracting 2 from each side. And that cancels it out. So what we have left here is square root of 4x minus 4 is less than or equal to 4. All right? Well, we're getting closer now. We need to keep going. We need to get rid of some of these other numbers, but we can't at this point say add 4 to both sides. That won't work because this 4 here is stuck underneath this square root sign. So just like the other side of your note sheet when we were doing those equation ones, we need to get rid of that square root sign, and to do that, we square both sides. By squaring both sides, that square root and the power of 2 cancel out, and we're left with 4x minus 4. On the other side now, we got 4 squared, so if we square 4, we get 16. Now this is one you've seen before. We just got to keep going through and solve. Add 4 to both sides, and we get 20. Divide by 4. Now we're dividing by positive here, so we don't need to do anything with flipping the sign. We get x is less than or equal to 5. Now, that solution would say any number 5 or less should make our original problem true up here. So if we pick a number, say like, I don't know, 4, 4 is a number less than 5. If we were to put 4 in place of x here, this should come out and give us it. So if we did 4 times 4, that's 16 minus 4 would be 12. So we'd have 2 plus the square root of 12. If you take square root of 12, you're going to get like 3 point something. So adding to that would be 5 something. That would be less than 6. So it's saying anything less than that should work. The problem is not everything less than or equal to 5 is going to work with this problem. Let's say we take the answer of 0. 0 is definitely a number that's less than 5. So according to our answer right here, that should work. If you're taking a number less than 5, like 0, what we should get is something true up here if we plug 0 in for x. What's the problem here, though, if we do plug 0 in for x? Let's see. If we plug 0 in for x, what we're going to get is 2 plus 0 times anything is going to be 0. If we keep going here, we got 2 plus square root negative 4. Uh-oh. We got square root of a negative. That's a problem. This isn't going to work out if we have that. So not every number less than 5 is going to work. An answer like 0 doesn't work. And the reason is we need to see what is the domain of this. What numbers can we actually plug in for x for this to work out? So we got to figure out what numbers, what's the domain on this one going to be. There's 2 ways you can get that. One way would be to graph it out. So if we were to graph this, we should be able to find what the domain is. So let's graph out and see what we get when we graph this one. If we graph 2 plus square root of 4x minus 4, here's what we get. What's the domain of this? Well, you can see what's the starting point, what's the first point that we see here in terms of x? Looks like 1. Here's another way. If you go to the table, you can look at it. Here, all these ones are going to give us errors if we put it in for x. What's the first value? 1. So we know in this one, as long as we're 1 or bigger, we can get an answer out of this equation. So our domain for this one tells us that x has to be greater than or equal to 1. So we need to add that into our solution. We need to be less than or equal to 5. We also need to be greater than or equal to 1. So that would be the answer. Now, if you want, you can combine these together into a compound inequality that would say x is less than or equal to 5 or greater than or equal to 1. So that would be another way to write the solution. So when you're finding the domain, you can graph it out like we did here to find it out. Another way to do this, to find that same domain, if you don't want to graph, would be to look at what's underneath the radical sign. If you take that and you set it greater than or equal to 0, you'll get the same thing of x being greater than or equal to 1. Because square root's the smallest thing you can take a square root of is 0, if you set that greater than or equal to 0, you get the same thing. Add 4, divide by 4, and you get the same thing that we got here. So you can either graph it or set what's underneath the square root bigger than or equal to 0. All right, let's try another one. On the next one, number 8. We want to do the same thing here. Solve this and see what can x equal. Oh, let's do the same thing. We want to get rid of everything except this x here. So start out. Looks like we need to subtract a 1. All right, so we got that. And I get square root of 2x plus 2 greater than or equal to 4. Undo the square root with a power of 2. That's going to cancel out. Got 2x plus 2 greater than or equal to 4 squared is 16. Subtract a 2. Divide by 2. And we get that x is greater than or equal to 4. All right, so that's the answer we got. But again, check the domain. What do you get for the domain on this one? You could, two ways of doing it again. You could take what's underneath here, put it greater than or equal to 0 and solve that for the domain. And we get subtract 2, divide by 2. X has to be greater than or equal to negative 1. Or again, you could graph it to do the same thing. If we graph this one out, we should see that it has to be bigger than negative 1. And yep, looking at the graph, it is bigger than negative 1. Okay, so let's put these together now. We know we have to be greater than or equal to 4 to have an answer, or to make this one true. The domain says it has to be bigger than negative 1. Well, in this case, if you look at the symbols, see on this one, the symbols are pointing the same way. They weren't doing that on the last one. If we have to be bigger than 4 to make this true, we are automatically going to be bigger than negative 1. So in this one, this is just your answer here. We don't need to include the domain because if you're greater than 4, you're automatically going to be greater than negative 1. 4 is a bigger number, so having this is just kind of redundant. It's just kind of saying it twice. As long as we're bigger than 4, we'll definitely be bigger than negative 1. All right, let's try one more, and then you guys try one. On number 9, kind of the same deal. We want to solve this one. So let's see what we get. Add 2. All right, so here's what we got now. Less than 6. We need to undo now our square root because we can't touch anything underneath that square root, so we undo it. Square both sides. And I got 4x minus 4 equals 6 squared would be 36. Add 4 to both sides. Divide by 4. Looks like x has to be less than 10. Okay. Is it anything less than 10? Well, let's check domain. If we check the domain, that means whatever's under that square root over there has to be bigger than 0 because you can't take anything less, square root of anything less than 0. If you solve this out, divide by 4, it looks like x has to be bigger than 1. So in this case, since these inequality signs are pointing different ways, one has to be greater, one has to be less than, we do need to combine them together to get our answer. So if we put these two parts together in our answer, x has to be less than 10, and it needs to be bigger than or equal to 1. That's the solution set for this one. All right, why don't you guys try number 10 out here. So number 10 on your worksheet's another one of these. Try it out on your own. Why don't you kind of pause the video here, you guys try this one, see what you get, and then once everyone's had a chance, we'll why don't you hit play again and we'll see how you did. Okay, let's see how you did on this one. Should have subtracted 4 here to start. Now you got square root of 3x minus 6 less than or equal to 3. Square both sides. And now we have 3x minus 6 is less than or equal to 9. Add 6. Divide by 3. Looks like you got to be less than 5. But check the domain too. If we check the domain here, whatever's underneath that square root can't be anything negative, so it's got to be bigger than or equal to 0 if you solve this. Looks like x has to be bigger than or equal to 2 in order to not get square root of a negative. So if you combine both of these parts up into your answer, we see that x has to be less than or equal to 5, greater than or equal to 2. That's the solution. All right, so inequalities, you got to check domain to make sure domain is satisfied on those problems. One last one. This is a word problem. You're probably going to see at least one word problem on your worksheet here. Let's read through it. It says the ponderal index P is a measure of a person's body based on height h in meters and mass m in kilograms. One such formula given here is shown. A 70 kilogram person is 1.8 meters tall and has a ponderal index of about 2.29. How much weight could such a person gain and still have an index of at most 2.4? All right, we got a lot of stuff going on there. But anytime they give you an equation, probably important to the problem. So we're going to be using this equation for sure here and putting some stuff in there. Let's see what we know. Well, they did tell us that a 70 kilogram person, okay, 70, that's a weight. Do we have anywhere in this to put a weight? Well, I don't think so. They don't, but we could put it in for the mass, and we could put 1.8. We could put that in for the height, and we should get 2.29. So they already kind of did this one already and found out what it equals. So that part's already done. We want to focus more on this next part. How much weight? Okay, weight. That means we're solving for the mass. We're trying to find M. Could a person gain and still have an index of at most 2.4? Okay, that's the index. That's P. Okay, so what we need to do is find M, plugging in P, but we also don't have the height. Well, we're probably assuming that this person's not going to grow anymore. So their height should still be 1.8. So let's fill in what we have here. Our index is 2.4. We're solving for M. Our height, 1.8 meters. We're assuming the person's not going to be growing. So if we solve that, that would tell us what the mass or the weight of this person should be. Well, let's solve. We want to get M by itself. How do we get M by itself? Well, looking here, it's being divided by 1.8. We would have to multiply by 1.8. Undo it. So if we do a little multiplication there, you're going to get 4.32. All right. So now we're close to getting M by itself, but we got that cubed root on there. How do we get rid of a cubed root? Well, just like we did on some of those problems on the front of your worksheet, to undo a cubed root, you want to cube both sides. So we need to cube both sides now to find out, because that'll cancel out and we'll just be left with M. So if you go on your calculator and cube 4.32, you should get the answer. And if we cube that, it looks like we get about 80.62. So it looks like that person could weigh up to 80.62 kilograms. Now, is that the answer? Well, it says how much weight could a person gain and still have an index of at most 2.4? Well, they can get up to that weight. They started at 70 kilograms, so how much could they gain? I think to answer the question here, we have to do a little subtraction. If we subtract the original weight from the weight they could have at this index, we would get they could gain up to 10.62 kilograms. So that would be the answer. All right, you have a worksheet. Try these problems out. We'll check them tomorrow when I come back, and good luck.